Morning. Welcome to the lecture on numerical methods. So in this lecture I am going to discuss about how to find the approximate root of the equation by using regular Falsi method and Newton-Raphson method. The equations like algebraic equation and transcendental equation. So first we will see what is meant by algebraic equation and transcendental equations. Algebraic equations are nothing if the equation contains algebraic quantities like x cube, x square, 3x and constants. So such an equations are nothing but algebraic equations. Example, x cube minus 2x plus 5 is equal to 0, x cube minus 4x is equal to 0 and so on. So transcendental equations are nothing. It contains non-algebraic quantities like trigonometric functions, exponential functions and so on. So such equations are nothing but transcendental equations. So say for example, cos x minus x e power x is equal to 0, cos x minus 3x plus 1 is equal to 0 is an example for transcendental equation. So here I am going to discuss only about regular Falsi method. The formula for regular Falsi method we'll see in the next slide. So now actually this regular Falsi method can be applicable to find the real root of the nonlinear equations. So the formula for regular Falsi method is x is equal to a into f of b minus b into f of a divided by f of b minus f of a. So in the formula we have to note few points. The value of a should be less than b is the first condition, and a and b should be very close. Like if the difference between a and b is very least, we can get the approximate root very quickly. So for my convenience, for in all the problems I am taking the difference between a and b's 0.1 to get the approximate roots very quickly. So let's see few examples on regular Falsi method. The first example is compute the real root of the equation x log x with base 10 is equal to 1.2. Correct to 4 decimal places. So your given function is x log x with base 10 minus 1.2. I will take, I'm shifting that 1.2 to LHS. I'm taking that whole thing as a function f of x here. So since here the function contains log x with base 10, in the calculator use log symbol to compute the values. So now the next step is we have to estimate the values of a and b. So already I told like a should be less than b and a, the difference between a and b should be very close. So I'm going to start replacing the values of x is equal to 0, 1, 2, 3 till I get one positive value and one negative value. I'm replacing x is equal to 0. The value will be 0. I'm taking x equal to 1. If I replace x is equal to 1 in the function, I got the value is minus 1.2, which is less than 0. I'm replacing x is equal to 2. I got f of 2 is equal to minus 0.6, which is less than 0. Similarly, I'm replacing x is equal to 3. I got f of 3 is equal to 0.23, which is greater than 0. Since here we can observe that one I got a negative value, one I got a positive value. So now we can assume that the roots lies between 2 and 3. So now I'm going to find the 0.1 difference between the values 2 and 3. So I'm starting with the 0.1 difference. So I'll start with 2.1, 2.2, 2.3 like that. So if I replace x is equal to 2.1 in the function, I got minus 0.5233. If I replace x is equal to 2.2 minus 0.4466, which is a less than 0. So since continuing like this till 2.7, I got the value is negative, that is minus 0.0353. I got it. At x is equal to 2.8, I got it 0.0520, which is greater than 0. So one value I got positive, one value I got negative. So we can stop the process here. So and we can observe that 2.7 is less than 2.8. The condition A is less than B satisfied here, and the difference between 2.7 and 2.8 is 0.1. So and also the one value is negative and one value is positive. So we can take A is equal to 2.7, B is equal to 2.8 according to the given conditions. So now I'm going to start iterations. So in the first iteration, I'm going to compute the value of x1. So the formula for x1 is a f of b minus b f of a divided by f of b minus f of a. So now in this formula we have to replace the value of a and value of b, and also along with that we have to replace f of a value, f of b value. This has been computed already in the previous process. So if we simplify all these values, the solution will be x1 is equal to 2.7404. I got it. So this is the value for first iteration. So now what I will do means I am going to replace this x1 value in the given function f of x. So I am going to compute f of x1. So in place of x in the given equation, I am replacing x is equal to 2.7404. So after replacing, I got the value is minus 0.0021 less than 0. Now the question is, now which one has to take a, which one has to take b? So in the previous iteration, the value of f of a was negative, right? So here also I got it, f of x1 is negative. So I can take a x1 value as a value and keeping previous b as it is. So in the iteration 2, I am taking a is equal to 2.7404 and b is equal to 2.8 and computing the value of x2. So replace a and b in the equation along with f of a value and f of b value. So after simplifying, we'll get the answer is x2 is equal to 2.7406. So next is iteration number 3. So to compute iteration number 3, before that we have to replace the value of x2 in the given function f of x. So what I will, so after replacing the 2.7406 in the function, I got minus 0.004, which is also less than 0. So according to the previous iteration, so previously a was negative, so here also I can take this x2 as a value to compute the next iteration. So in the iteration number 3, I am taking 2.7406 as a and keeping previous b 2.8 as it is. So if we replace all these values along with f of a and f of b in the x3 formula, so after simplifying, I got the value like 2.74046. So now by comparing previous x2 iteration with x3 iteration, the value is same till 4 decimal places. So we can conclude the approximate root is 2.746 after 3 iterations. So we'll see one more example on regular Falsi method. So here the problem is like, use the regular Falsi method to find the real root of the equation x cube minus 2x minus 5 is equal to 0 correct to 3 decimal places. So same thing here also, take the function as x cube minus 2x minus 5, start replacing x is equal to 0, 1, 2, 3 and so on. So if I replace x is equal to 0 in the equation, I got minus 5 which is less than 0. If I got x is equal to 1 in the equation, I got minus 6 which is less than 0. If I replace x is equal to 2 in the equation, I got minus 1 which is less than 0. If I replace x is equal to 3 in the equation, I got plus 16 which is positive, which is greater than 0. So I can assume like the roots lies between 2 and 3. So now we'll find the 0.1 difference. So I'm going to replace 2.1 in the function. So on replacing f of 2.1, I got positive immediately. So in the previously f of 2 is negative. So I can take a is equal to 2, b is equal to 2.1. So in the same formula, in the same regular Falsi formula, x is equal to a f of b minus b f of a by f of b minus f of b, I can estimate the value of x1 here. So if I replace both the values in the equation along with a, f of b, b, f of a, so I got the x1 value like 2.0943. So now if I replace x1 value in the given function f of x1, I got negative value. So previously I took a as a function of negative, like in f of a I got negative value, here f of x1 I am getting negative. So I can take a is equal to 2.0943, keeping the previous b 2.1 as it is. So in the iteration number 2, I am taking a is equal to 2.0943, b is equal to 2.1 along with f of a and f of b. I am going to compute x2. So if I replace all these values in the formula and simplifying, the solution will be 2.0946. I will get it. So comparing the previous iteration and present iteration, the values are same. So the approximate value will be 2.094. We can write it. So in the same way we can solve many problems here. So some sample problems for the practice I have given here. The first one is find the real root of the equation cos x is equal to 3x minus 1 correct to 3 decimal places. So here we can observe the function contains trigonometric functions. So in the numerical method, if trigonometric functions comes means please keep the calci in the radian mode. So then only we can easily estimate the values of the trigonometric equations. So if we solve this equation, the answer will be 0.607, will get it. And similarly, find the fourth root of the 12 correct to 3 decimal places by using regular Falsi method. So here are some hint I am giving to estimate the fourth root of 12. So first take x is equal to fourth root of 12 on simplifying this, we'll get x power 4 is equal to 12 or x power 4 minus 12 is equal to 0. I can write it. So I can take the function like f of x is equal to x power 4 minus 12. So on simplifying this equation, the answer will be 1.1861, we will get it. So I'm giving one more sample also. Find the root of the equation x cube minus 4x minus 9 is equal to 0 correct to decimal places, 3 decimal places using regular Falsi method. Answer will be 2.706. So these all three problems you can practice in the home only. So in the next lecture, I am going to discuss about Newton-Raphson method. So there also I am going to estimate the approximate root of the algebraic and transcendental equations. Thank you.